Alright, let's give it a try here. So we'll see. We'll play it back. Okay, so inequalities, numbers, inequalities, and absolute values is kind of focus. A couple things to remember. Rational numbers. What are rational numbers? They're any numbers that can be written in fraction form. They can be terminating or repeating decimals. So you know 2/3 is 0.6 repeating. 1/4 is 0.25. Those are all rational numbers. Irrational numbers are numbers like pi, roots, like root 2, root 3, numbers that are non-repeating, non-terminating. Real numbers are the combination of those. Anything real is something that has an actual value. Okay, we get into non-real stuff with imaginary type numbers, but that's not a basis of this class at all. Okay. So interval notation. So this is kind of important, understanding how to write the brackets and whatnot. We did use interval notation in Math 3 a little bit, but mostly set builder. So interval is a little bit quicker, so we'll kind of use that a bit more in calc. So interval notation, again, rounded brackets is not included. Squared brackets is included. So that's why these are open dots here, open dot versus closed dot, closed dot. Okay, so to go through here on the class exercise here and just go ahead and make the number lines here. So for example, I'm just going to put a spot here for A with an open, a spot for B with a closed, and then connect them. And that's all you're doing. Okay, and I have a closed A this time and an open B. Like that. Zoom this in a little bit so we can see. Okay, and then we have a open A, and then it goes to infinity. Infinity can never be included because it's not a value. Remember, A to infinity is the same thing as just greater than A, right? Because it's A and everything larger. Okay, and then B to negative infinity. So you have a B, and you're going the opposite direction. Open dot, like so. Remember, the open dot on A and B there have nothing to do with the infinity. You can close the A and B, which we'll do now. If you had A infinity included, it'd be a solid A, and then still to an open dot, not open dot, but like an open infinity. And then closed dot B to infinity. And if something is all reals, another way of doing all reals in interval notation is negative infinity to positive infinity. That means everything. Okay, and that would just be just all the way across. Okay, any questions on that one? Okay, so again, just in review, open brackets means not included. Okay, open brackets is the same thing as less than and greater than. Closed brackets means included, and that means less than equal to, greater than equal to. Okay, so intervals are separated. For example, a solution in which x is less than 4 or greater than 9, x less than 4 or greater than 9, we can use the union symbol to simplify the notation. So union just means combining them. Okay, so it's like two separate sets. You can't write it as one smooth set. So for example, negative infinity to 4 and then 9 to infinity. So you write it as a union, it's called. So this is just like writing two intervals together. So you can do it with 3. Like if there's a third piece, you could put another u here. Okay, but union is putting sets together, okay, that aren't overlapping. Questions on that? Nope. All right, let's do a couple here. So we got some solving inequalities, so just see what you remember that. Remember, you treat the inequality as an equal sign, and you just solve as you normally would. So for example, on this question here, I would get my x's together first. I'll go ahead and move the 5 while I'm at it. So you have, that's gone, that's gone. You have a negative 4 less than 6x. Divide the 6, divide the 6. I'm going to rewrite it the other way just so it's easier to read, but if you don't have to. X is greater than, because it was greater than next to the x, negative 2/3. So x is greater than negative 2/3. I just wrote it from left to right. It's a bit easier for me to read. You don't have to. Okay, you can still read it the other way. So how would I write that in interval notation? So greater than negative 2/3. So that means I have a round bracket. I have negative 2/3 to infinity. So negative 2/3 to infinity is your greater than 2/3. Okay. Questions on that? All right. So in this one here, so here we have two inequalities. We just kind of do it at the same time. You have to do it like 3 sections. So for example, I'm going to add 2, right? I'll have to add 2 to the left and the right due to all sections. Okay. So like that. So then you have 6 less than equal to 3x less than equal to 15. Divide 3 to everything. 2 less than equal to x less than equal to 5. So x is between 2 and 5, right? That's what that means. X is greater than 2 but less than 5. Yep.
Why does it change to less than equal to? Yeah.
You're right. It doesn't. It is just less than. Thank you. Okay, just less than. Good. So that means we're between 2 and 5 still, though. So that means square bracket on the 2, open bracket on the 5. So you're between 2 and 5. Okay, so if you remember Math 20, we did kind of that case analysis. We're going to be doing that quite a bit in Calc as well, like testing the intervals to seeing if they work. Sometimes there's critical values of different things we have to navigate to see. So it is a little bit more experimental in terms of figuring it out. So I'll kind of show you what I mean here. I think it makes more sense to do it in B. I think in A, if you remember your positive piece, negative piece thing for Math 20, it's pretty simple, but I'll do it both ways. I'll show you. So what we're going to do first is we're going to get everything together on one side. So I'm going to move the 2x and the 8 over and make it less than 0. And what we're going to do is we're going to factor x minus 4, x plus 2. And so that means we have a couple things to think about here. We have a value of 4 and a value of negative 2 that we're calling like critical values, okay, that are zeros. So what we're going to do is we're going to test around those. So we're going to look at x less than negative 2, between negative 2, not equal to, sorry, between negative 2 and 4, and then when x is bigger than 4. There's 3 sections. Let me just draw this just real quick for you. Remember in Math 20, we did negative 2 through 4. So that's what that parabola looks like. If we want it to be negative, that would be this piece, right? That's the piece that's down. Okay. So I'm expecting when I do these tests for this one, I'm expecting this one to be the correct spot. I'm showing you the cases now because when we get to this one, like on B, you're actually going to have to test. Okay, so you're saying, well, why are you doing this if we know that for the parabola? Fair, but you're not going to know that for all these type of functions. Okay, so watch. If I try less than negative 2, okay, so let's do negative 3. If you put negative 3 in here, I'm putting it right here, that's 9 plus 6, 15 minus 8 is 7. Is 7 less than 0? No. So that's no good. Between negative 2 and 4, I'm going to try 0. 0 is the easiest. Put a 0 in, I get negative 8 less than 0. That's good. Try something bigger than 4. Let's try 5. 25 minus 10 is 15 minus 8 again. I get 7. No. So this is your interval of where the answer is. So you would write that as negative 2 to 4 with rounded brackets. Questions on that? Okay, so what we're going to get into as we do these more, we're talking about critical values. So a critical value on this for B, or how about you tell me, what do you think a critical value is for B? You don't know what critical values are, but what's just a value that's probably significant? Why? Okay, 1 is a critical value, good. Because 1 makes the bottom 0. What else would be something of interest? 0, because you put 0 on top, you get 0, and that's equivalent to the other side. So good. So we're going to be looking at 1 and 0. So the gaps of values here is essentially negative infinity to 0, 0 to 1, 1 to infinity. Right? That's our sections of values. Okay, these will all just be rounded brackets because it's not equal to in the problem. So we're going to test these. We're going to test these sections to see which ones are true. So what's something between 0 and negative infinity? Negative 1. Try something simple, right? So negative 1 would be negative 1 over negative 2. That's 1/2. Is 1/2 greater than 0? Yes. That's a good section. Try between 0 and 1. Let's try 1/2. Have to use a fraction here, unfortunately. Be 1/2 over negative 1/2. Because 1/2 minus 1 is negative 1/2. That's negative 1. Is negative 1 greater than 0?
No.
No. And lastly, 1 to infinity, let's try 2. 2 over 1, which is 2. Is 2 greater than 0? It is. So the outside sections are solutions here. So we'd have a solution of negative infinity to 0 in union with 1 to infinity. Because it's two separate sections. All right, any questions or concerns on that? All right, let's look at a couple more here. Ooh. Where'd I go here? Oh, I switched pages. Okay, here we go. So I got another one here. So we're going to go ahead and factor that again. So that factors to x minus 3, x minus 2. So that means we're looking at 3 and 2 for our critical values, our values of significance. So we're going to look at negative infinity to 2, 2 to 3, and 3 to infinity. So negative infinity to 2, let's try 0. If you put a 0 in the top there, you get 6 less than or equal to 0. Nope, 6 is not less than or equal to 0. Okay, if you try 2.5, okay, might need a calculator for that one if it's just because it's decimal, but you can put down there. You have 2.5 squared minus 5 times 2.5, and then plus 6. It gives you negative 0.25 or negative 1/4. That is less than or equal to 0. Then we try 4, 16 minus 20, negative 4, so I get 2, less than or equal to 0. It is not. So your answer for this one is just, sorry, it should be is equal to, so these should be closed brackets. So 2, 3, closed brackets is your solution for that one. Okay. All right, the uglier rational equation one again. So what's our critical values for this one? Okay, close. See how it's not 0 on the right? So negative 2 isn't now. Okay, so what we're going to do is, okay, 3 still is, because 3 still causes a non-permissible. So 3 still is. But we can times this over because something's over here. So we can actually do some algebra here to solve. So we're going to do 2 plus x less than or equal to 3 minus x, right? I times that 3 minus x over. And now I'm just going to solve this. We're going to add x. We're going to subtract 2. I get 2x less than or equal to 1. So I get 1/2. So 1/2 is another value that we're going to pay close attention to. Questions on that? So the difference is it wasn't equal to 0 there. So that top being 0 was not a big deal. Okay. Yeah. Okay, so what we're going to do now is we have our kind of sections will be then. We have negative infinity to 1/2. Sorry, that's included. we have 1/2 to 3, and we have 3 to infinity. Is our 3 sections. Okay, negative infinity to 1/2. Let's try 0. 0 is a good one to try. If you put 0 in here, you get 2/3 less than equal to 1. True. 2/3 is less than equal to 1. So I just put 0 in. I tried 0. If you put 0 here, this is just gone. The x's are just gone. It's just 2/3. Okay. If you want me, I put try 0. Let's put that there so you know what I tried. Okay, between 1/2 and 3, you might as well try 1. Try 1, so that'd be 3/2. 3/2 is not less than equal to 1. Okay, and the last one, 3 to infinity, let's try 4. 4 would be 6/-1, which is -6. Is that less than equal to 1? It is. So your answers again are a union of negative infinity to 1/2, square bracket 3 to infinity, round bracket. All right, so got a little absolute value, and that'll be it for this piece, and then we'll have some time to work on those exercises, okay? All right, so remember the absolute value, the whole thing with absolute value, guys, is you have to do the positive piece and the negative piece like we did in Math 20, okay? So you have to separate it, the positive and the negative. Why? Because absolute values are a combination of the positive slope line and negative slope line. They make a V, okay? So that's what we're doing. So in this case, you just solve the left side as you see it normal. So I would just go -2, divide 3, divide 3. I have x greater than or equal to 2/3 as a possibility. There's a critical value, you could say. For this one, I like to distribute the negative, just keep myself organized. So I'm going to add 2 this time. Don't forget the rule of dividing by a negative with inequality. You have to flip it. So x is less than or equal to -2. So here's the 2 values. 2/3 and -2 are your important values. So that's the ones we're going to test. So we are going to do negative infinity to -2 included, -2 to 2/3, 2/3 to infinity. We're testing those 3 sections again. I'm just going numerical order. If you're not sure how I'm getting those, I'm just going the smallest to biggest. So negative infinity to the smallest between the 2 numbers, and then biggest number to infinity. Okay, so I'm just going numerical. All right, so let's try -3. So go up the top here, put -3 in, you get -9. -9 plus 2 is -7. Absolute value of -7 is 7. Is 7 bigger than 4? Yes, that one worked.
Does it have to work for both for it to be a valid solution, or can it only work for one of them?
What do you mean by work for both?
Like work in both the negative case and the positive.
No, because we just go to the absolute value case. Yeah, just go to the original. In terms of would it work, it might not work for both of those. Yeah, you want to go absolute value. Okay. Between -2 and 2/3, might as well try 0. So you try 0, you get 2. Absolute value 2 is 2 greater than or equal to 4. It is not. Okay, and lastly, 2/3 and infinity, I might as well try 1. Okay, if you put 1 into the top, keeps over zooming out, maybe get to lock that, don't I? Okay, if I try 1, it would be 3 plus 2 for 5. Absolute value of 5 is 5 greater than 4. It is. Okay, so we have another union situation. We have negative infinity to 2, or -2, excuse me, in union with 2/3 to infinity. Would be your solutions there. All right, this next one's a little bit messy. Okay, a little bit messy. The last one is the good news. All right, so class example 4, solving for absolute value inequalities. So the problem here is we have two absolute values. So the both absolute values both have a what? A positive, negative, right? So we have to do that so we have all four combinations. Positive, positive, negative, positive, positive, negative, negative, negative. Okay, so let me explain that again. This can be positive, negative, this can be positive, negative. So that yields four possibilities. Four possibilities, okay? So let me show you what I mean. So the first one would be just positive, positive. So x over x minus 1 greater than 1. That's your first one. We'll do a little dashed line here. My second one is making the bottom negative. Like that. It's your second option. Okay. Your third option is making the top negative. Like that. Okay. And then your fourth option is making them both negative. Like that. Okay. So if you want to help yourself organize, it's a plus plus, plus negative, negative plus, negative negative. And now we have to solve all four of them. Okay, and see what they do for us. Okay, so we just do this here. If I times the x minus 1 over, I get x greater than x minus 1. You see this one ends pretty quickly because you get 0 is greater than negative 1. There's no x's, no solution. You have no solution with that one because the x's cancel. Okay. This next one, we'll times this over, the whole thing over. So that would give me, so this one, you're not going to, we're kind of thinking about it in terms of it's negative x plus 1 and we're times that whole thing over. So it's not timesing by a negative in this case. I was confused, I did by notes to tell you the truth. But it's not because I put it through. I'm not multiplying by negative 3, I'm just multiplying the bottom over. Okay, so that's going to be x greater than negative x plus 1 over here. Add the x, divide the 2. Like that. Okay. All right, the next one. So that is one of our critical solutions we'll be looking at. So 1/2 is something that we're going to look at. Times it over again. Negative x greater than x minus 1. Subtract x, negative 2x greater than negative 1. Now we will flip x less than 1/2. Okay, so just 1/2 so far is a critical value. We'll have one more we'll get in a second. This one you'll see when I do it again, this is again negative x plus 1. You push that over, you get negative x greater than negative x plus 1. The x's cancel again. It's the same situation on the other side. So that's a no solution. Okay, from the start we did forget one of the critical values. What's one critical value to start? Yeah, 1, right? Can't have 1 on the bottom, it makes it 0. Okay, so you have 1 and 1/2 of our critical values. 1 and 1/2. This one, and then this one from the bottom there. So that's going to be our what we're trying to do here. So we're going to negative infinity to 1/2, not included, 1/2 to 1, 1 to infinity. That's what we're testing. Okay, negative infinity to 1/2, let's do 0. I'd get 0 over whatever, the negative 1, which would be 0. Is 0 greater than 1? No. So that first one's a no. 1/2 to 1, we'll try 3/4. Okay, if I try 3/4, I get 3/4 over a negative 1/4. But then that's going to be, here, I'll kind of show you what I'm doing here. It'd be 3/4 over 1/4 because it's absolute valued. So that gets you 3. Is 3 greater than 1? Yes. So that one works. And lastly, 1 to infinity, let's just use 2. 2 over 1 is 2, and that one works. Because 2 is bigger than 1. So we have 2 chunks there that work. 1/2 to 1. In union with, I want to ask why, 1 to infinity. Why did I do a union here and not just say 1/2 to infinity? 1's not included. Yeah, see that? I said all the way to 1 but not 1, and then all the way after 1 but not 1. So what you're saying there is pretty much 1/2 to infinity is good except 1. That's what that's saying. Okay? Yeah, like set builder you could say like x greater than equal to 1/2 but not 1. Yeah. Okay? But we'll use interval mostly. All right, good. Any other questions? All right, good.